Hello, everyone. So I'm curious, well, you probably showed up, right? And you thought, I'm gonna go have some free food and listen to some talk, learn some stuff. You didn't know you'd have to participate, but you have to participate in this. That's the fun part. Um, what interested you to come out here when you hear multi-model? That's obviously why we're here, right? So I'm curious, I'll put a few of you on the spot, but when you hear multi-model, what does that mean to you? What first comes to mind?
Yeah, so I'm running Cassandra. I've got Oracle,
Yes,
both of them, and we use this as kind of like a multi-model query.
excellent. And we talk about that. We talk about that, so yes.
A single engine storage engine. I think because you all have different storage engines, but this would have more storage engine. And those would all basically model.
Yeah, exactly. What else?
For me was the concept that you can store directional set attributes at the node level where you can, for example, have lists and such that they're not really restricted
Right.
like other products.
Yeah, right. Denny?
The world is a complex place,
Right.
and one model does not fit all.
Very true.
Many different models, and having one system that can handle all kinds of data, just at a very high level, makes a lot of sense.
It does. Anyone else? Yeah.
Singular language of creating, basically.
Say that again?
Singular language of creating.
Right, right.
Kind of when you have multiple different data stores, it becomes nuanced sometimes to keep up with how execute.
Yeah, absolutely true. Do you have a comment? That's fine. It's fine. Anyone else want to volunteer right in the front row here? You don't have to. Okay. So we all have different perceptions of what multi-model means for good reason, because in the industry we use it all over the place and we mean different things. The Wikipedia definition is pretty simple, but in this case, a multi-model database is what? Designed to support multiple data models against a single integrated backend. True. You can think of a multi-model database system that does this, but it's much more than just this. The term multi-model, actually our founder, Luca Garulli, he's the one who came up with this term. And the first time he used it publicly, internally we used it for years and talked about it. It was just, it was just a way of describing it. But the first time it came out was at this conference in 2012 when he used it. So it's kind of interesting. What's the alternative world we talked about already? So we have multi-model, we have the old-fashioned way, and we have this polyglot persistence, right? We talked about that. So yeah, using different data storage technologies to handle varying data storage needs. That's Wikipedia again, but it applies. So here's an example of a polyglot persistence. Maybe we have this flight reservation application. What we could do, we could have transactions and do ticket purchases in the SQL Server. We might want to pull up some kind of seating or aircraft model information. We might store that in MongoDB, JSON documents perhaps. We want to do some kind of traversals to find out shortest path perhaps between airport routes. We are using Neo4j for that because it's graph, makes sense. We do session caching on the front end for the client side using Redis. It's very possible. We could store audit logs and many other things in Cassandra. So, I mean, it's a contrived example, but if you're in this space, you've seen this happen, and much, much worse, much more than this. There are many, many, many ways of implementing multi-model. It's not just a single database system. We've touched on the database system, right? But more often, it's the interface that's multi-model, meaning that you can, in a single database system, have multiple interfaces supported all in one package, or you can support multiple models in a single interface. And I'll give an example of that. And we'll actually go through quite a few of the multi-model databases out there and talk about how each one implements it. But then you also have multi-model at the storage layer, where you have a single storage system that might store multiple different kinds of models within it, right? And we'll touch on that with an example. So database system multi-model. I think we have a pretty good idea of this, but combines multiple technologies into one. DataStax Enterprise is just one example I have that I pulled out. Under the hood, it uses Cassandra. They call it DSE Core, but it's still Cassandra, their modified version of it. It has Graph bolted on top of it, but it's still a model. It has Solr for full text and geospatial type index lookup. It has Spark built into it as well on the side, so you can do analytics at the same time. So, and that actually leads me into something more interesting we'll touch on in a second. But you can see from the database system, which is DataStax Enterprise, you have multiple models and multiple implementations all connected together. Multi-model interface, though, is a little different in that the interface allows access to different technologies, okay? And the underlying storage through a similar and related API or query language. So here's an example. In OrientDB, the Java API allows you to talk to documents, allows you to talk to vertices and edges in essentially the same way. I'll show you an example a little bit later on, but with very few changes to the code, you can talk to multiple models within it, but all through the same interface. Same thing, as Jerry touched on, the SQL in OrientDB allows you to, you can retrieve documents and vertices and edges. You can do traversals through it. You can also do key value if you want to. We even have an object implementation too. But this idea, so think of it, we have the multi-model database systems up here, which might contain multiple implementations underneath the hood. But then you also have multi-model interfaces within those. It might be a single database system that does this, but the interface itself has multiple models that it supports. Yeah, sure.
So, from that aspect, we have different type of memory storage mechanisms for each one of those storage engines, right? One is LSM, there's B3, there's all these encoding between disk memory. If you do all these 3 things or 4 things or 5 things all at the same time, looks like there'd be some kind of like concurrency mess.
Well, that's true. And that's where these multi-model database systems have to handle that. Going back to our DataStax Enterprise example. So for Cassandra, you've got SS tables under the hood being stored, right? For Graph, well, it's actually bolted on top as Cassandra tables, and relationships are built from that, but it's still SS tables under the hood. So that's good. But then for Solr, it has its own Lucene indices, completely separate from that have to be. What about it?
How would that happen if you run a graph on top of SST tables and compact them over here? One is just things get jacked up.
It doesn't, because it's just a layer built on top of Cassandra tables of how it's actually implemented. So you could roll it yourself if you wanted to, and really Titan, which is now Janus Graph, but Titan, that's what they did. You know, they implemented Graph on top of Cassandra to get these distributed benefits out of it. And then DataStax acquired Titan and they re-engineered it actually from the ground up, but there's a lot of similar architecture in there. But you do, and you can run into these synchronization problems because you're bolting different technologies together. It's, you know,
That's only one machine.
yeah, it is.
Stuff distributed outside.
Well, yeah, exactly right. Now with DataStax Enterprise, it has layers built into it so it can intercept the different calls. So it knows, as an example, if you write a CQL statement where you're updating the data and there is a Solr query or Solr table associated with it, just an index, it can capture that and it will update Solr, but it's done asynchronously, just like a materialized view is updated asynchronously. It's fast, but there's still that little bit of lag, and you could potentially get out of sync if you had a node that went down before the data were replicated to any of the other nodes that also supported Solr. So it is an issue, can be an issue, right?
So what about the other perspective of how you do mutex and semaphores, all that kind of stuff, when you have all these 3, 4, 5 different models working on one database? If we're going to have race conditions, how bunch of stuff going on. How does it deal with that?
Well, I mean, you can, right? I mean, one of the common things that's used, Cassandra's used for, you can't actually use it for distributed locking. But then we have all these other vendors like Hazelcast and Apache Ignite that has, and many others, that have these built-in mechanisms too for distributed type locking or distributed access control, right? Which often are on top. OrientDB still uses parts of Hazelcast for node detection. We used to use locking from Hazelcast, and we used to use the queues in Hazelcast, but just because of these limitations we're talking about, we actually ended up writing our own because we ran into problems.
Transaction processing, abstracting away the transactional layer from this using Zookeeper.
Potentially so.
It has its protocols, but is the multi-model very good for transactional processing as a database, or is it much more?
Well, it depends on the implementation, right? If your database system implements it natively and can support, say, transactions like we're talking about, then yes. So in this case, Orient is a good example of a win because all these models are natively built into it. So if you have transactions, it's still going to be part of the system. It's not going to be something that eventually happens or might get out of sync or might not happen because you're bolting different technologies on. But I'm just showing examples here of multi-model interfaces. We have multi-model database systems that bolt different technologies together, different models that are implemented, right? Then we have the multi-model interfaces, which really just allows us to communicate to that underlying storage system in the implementations, whether it's graph, whether it's document, it could be pure binary type documents, it could be JSON documents, whatever. But you have a multi-model interface allows you to talk to these different models, but in a consistent way. I'll give an example here in a bit. And of course, we also have multi-model storage. What does that mean? Well, the different models you support are all stored in some consistent way. In this case, we're going to use ArangoDB as an example, and it natively supports JSON documents, graph, and key value. And it stores all this as collections. Now, natively, ArangoDB is really a key value type database that stores things as collections, but they've implemented graph on top of this with this, and then JSON documents, they're not actually stored as native JSON. It's not. It's turned into their own binary format and then is stored into collections. But the model representation is as a JSON document. You can retrieve it, you can put it in. Graph is a property graph, and key value is what you would expect it to be. The nice thing is, though, it all uses the same storage layer. So in this case, we have multiple models, one storage layer. That's a good thing. OrientDB has the same type of idea. You can have binary data and documents and graph, key value, all that's still stored in the same storage system. It's not something bolted on or outside of it running separately. As the other example was, we have Spark or we have Solar.